Well, as the title says, GraphQL, all you ever want to know, or just at least a brief overview. So here's what we're going to cover. We're going to cover what GraphQL is, what GraphQL is like to develop with. I'll give a short demo, and then finally, why does GraphQL make sense for JAMstack? Why does it interest all of you guys? So what is GraphQL? Well, GraphQL is three things. It's a schema definition, it's a query language, and it's a resolution framework. So let's start off with the schema. So the schema provides a strongly typed definition of all of your data. So right here we got describing a movie and the people who are in it. Right now it's limited to actors and directors. But this language that you see right here is called the schema description language for GraphQL. Or SDL, it's abbreviated a lot. And it's the way to write your schemas in a cross-platform manner. So the next thing that a schema describes in addition to your data is also what you can do with your data. So it describes queries and also mutations, and we'll get into that in a second. So queries. Queries allow you to fetch data. Everybody's familiar with a SQL query or a query of some sort, Google query. But in GraphQL, you actually specify your query exactly. So right here, what we're doing is we're grabbing a list of movies, and we specify everything we want to know about it, whether or not we've watched it, what the movie is, what the title is, what the year is, and the director. And as you can see on the right side, we have our output from the query, and it's exactly what we asked for. So mutations are how you actually interact with the GraphQL API. And so mutations define what you're going to do with that data. So for example, here we're adding a movie to our list. We're adding Die Hard, great Christmas movie. So we're adding it here, and we also specify the format that we want back. So we have the same information coming back, so now we have Die Hard appended to our list. So resolution framework. So GraphQL provides its own query resolution framework. So across multiple platforms, this framework varies a bit, but the reference implementation is GraphQL.js, and that's written by the folks at Facebook. So I'm going to cover that. So part of the most important part of the query resolution framework for GraphQL.js is this concept of resolvers. And so resolvers, what they do is this is where you hit the database. This is where you reach out to external services. This is where you concatenate strings and compute dynamic values. So resolvers describe how queries work and how mutations work. So as you can see, there's a lot of parity in GraphQL. So in our schema description language, we then have resolvers that correspond to each of the queries and mutations. So right here we have just sort of a fake database called watchlist, and it has very simple methods just for the sake of demonstration. Another thing that that has resolvers is actually fields on a data type. So like for example, the to watch data type right here has a movie field, and the movie field doesn't exist actually in our database. It could be pulled from some other service. So what we can do is we can define a resolver to go reach out to an external service and grab that data for us on the fly when the person asks for that information in the query. So this is an example of a resolver. Whoops. All right, so it's demo time. So here we go, we're back into the code, and what we have is we have the code that was on our slides before, and we have our schema type and we have our resolvers. And this is great to look at, but it's usually easier to visualize something, so I cooked up a React plus GraphQL app just to sort of demo what we have going on here. So to-do list is a typical thing, so I wanted to create like something, a little riff on that, a to-watch list. So we have right here, just a list of movies that we want to watch. So nothing super interesting, but we do have the GraphQL API running in the background. So right here, here's the data that we see in our app. and we can query it right here. If we were to say change taxi driver to we've watched it already, if we query again, you'll see that the value is here. And this is what's called graphical, and it's a built-in query explorer for GraphQL. And what's really cool about it is it provides a way to query, get the results, and then also see documentation that's dynamically generated about your API. So this is great. We have an app, we have a to-do app. We can change the data, we can do stuff. And now let's get into the details a little bit. I'll show you how, this is how our schema is defined, and now I'll show you how we query it in our app itself. So in our app itself, we're using a popular library called React Apollo. And so React Apollo provides higher order components for you to bind queries to components. So down here in our watch list component, we have a watch list query, and that corresponds to this query. As you can see, the top query right here, this watch list right here. And this is actually going to demonstrate one of the cool parts about GraphQL, is that my IDE actually knows about the GraphQL schema. So for example, if I wanted to modify this query and I wanted to add the movie title back, it already knows about the information. It does autocomplete, so schema aware tools. Now we're going to pop out of presentation mode, hopefully. Oh, okay, great. It stays zoomed in and I have no idea where I'm at. Yeah. All right, well, while I navigate, we'll have to do this thing. So, all right, so basically this is how this app is built. So what would be great, I was telling you about dynamic fields. It'd be great to add some more metadata to this. And one of the great things about GraphQL is its ability to easily stitch together content. And so let's use an API to enrich this data and to like get some movie posters, get some IMDb scores, and make us actually want to watch the movies on this list. So here, I'll pop back into presentation mode. All right, you guys can see it? Cool. So we have our toWatch object, and what we want to do is we want to add some additional information, some metadata. So let's add, we have the movie title. Let's add the actual movie object to this type. So let's add a movie. And ideally, we would want it to be a movie type. So let's define it as a movie type. Let's create our own type. So movie, and then what's in a movie? It's the year that it's made, and it's a string, or a strom, the director, and that's also a string. So okay, for sake of thing, and then we pop out of here, we'll go back to our graphical interface. So now with just a quick reload, we've updated our schema, and now we should have a movie object here, and we should have the year and the director. But as you noticed, we didn't implement the resolver, so we get nothing back for this thing. So you actually just need to hook up a resolver to this thing. So just for a simple example, as you can see, let me get back into presentation mode. All right, so you can see the parity from left to right. And we have our toWatch type, which we want to add a dynamic field to. So up here, what we'll do is we'll add that in over in our resolvers. So we'll add toWatch. Right? And then we want movie. So a resolver is just a function. It can return anything. If we had static data that we wanted to return, we could just return it here. So for example, if we said year, and then we just did 1985, right? And director, let's say Mark. So Mark was active when he was young. So if we run that over here, we'll see that we get the data back. And that's just demonstrating a really, really simple, the simplest type of resolver. You could have string concatenation, whatever you want. So using the power of source control, I'm going to implement a resolver for you. So we'll roll back. And all I'm doing here is I'm just doing a simple fetch using node fetch to OMDB, which is a free implementation of the IMDb database so that we can grab some movie information. So now let's save that. Let's pop back out of this mode, and let's go over here and run this, and boom, we got our data. So that's pretty cool. Now we have data, we have year, and we have director, but it'd be great if we had more. So I'm grabbing more data here. So let me add those in again using our sort of pre-baked movie, and here we go. We'll get our full set of data over here in our schema. So, oops. Huh? Ah, thank you. There we go. Now we got the director, and now, do we want a poster URL? Sure. There you go. Okay, cool. Now let's add that into our app. And so I'll demonstrate that over here with our presentation mode again. Up to the top. That's kind of annoying that you have to do that, but roll the punches. All right, so here we are. We're back in our thing, and we can go down to our movie component, and let's add those fields in. So I pre-baked a component that just had some basic styles, a poster, image tag, all the things we just pulled from GraphQL. And now is the time where I want to just show you what this thing up at the top is, this idea of a fragment. So in GraphQL, you get to pull your data from a database, but you have to do it explicitly, and you have to specify every single field that you want every time. So this can become really tiring, especially when you want the same thing a lot. So fragments are a way to save little snippets of queries so that you can reuse them. So it's not as verbose every time. And if you're repeating things within the same query, you can compose fragments in order to do that. So right here, what we have is we have watched and movie title, and we're using that in not only our list query, but also in our mutations to add the movie, rename the movie, or sorry, remove the movie. So let's just add them to the fragment, and then we'll add it to all of our operations. So let's add movie. And as you can, here, I'll just let it complete to save time. So there we go. We added all that information in, and that should all add up to a much better app. So here you can add, other things to our thing, like there, and we can see that it's a terrible movie, and then remove it from our list. So that's sort of like a quick demo of how to create an API with GraphQL, how to query an external service, how to build a React app on top of that. And this code will be available. It's up on GitHub right now, so you guys can grab it, play around with it, give me feedback on it, and hopefully make something cool with it. So anyway, back to the presentation. There you go. Thanks, Gerald. Everybody give Gerald a round of applause. So then why does this all make sense for this meetup, for JAMstack meetup? What is it about GraphQL that's especially effective for this type of environment? So number one is clarity, and I've really hammered in on this before. But basically, I like to say it's what you query is what you get. It's very literal. So if you are a front-end developer and you have no idea what's available on the back end for you, you can use the Schema Explorer. You can use tools like Graphical, like VS Code, like IntelliJ, different plugins to see exactly what data you have available. And then all you have to do is query it so that you can get it and you can build your product with that data. The other thing is flexibility. Like a lot of times, if you're coming from a monolithic environment, you're waiting for people to implement custom endpoints to get the data that you need. The right mix of attributes, maybe you need to do 10 calls to get the information that you want. So, you're not, it's really enabling for a front-end developer to be able to query exactly the information that you have. And it's not painful for a back-end developer to implement a GraphQL schema once and then have it be used in a multitude of different ways. So here you go from REST to GraphQL and you're very happy. And then I wanted to bring up something. So this is sort of the thing that people talk about all the time. And it's sort of a comparison to REST. And so which is better? And I'm sort of tired of hearing this because it's really an apples and oranges situation where REST is very prescriptive about what's going on. You have to use HTTP or HTTPS. You have to store your resources in a path. It's very prescriptive about what it does. And it doesn't prescribe a lot of the things that GraphQL does prescribe. Strongly typed schema, query language, the operations that you can do on there. Your RESTful interface has to interpret the HTTP verbs in order to interpret your intention. And so one of the things that's really cool and that I want to highlight is in this presentation, if you take something away, is that GraphQL doesn't have to be over HTTP. It doesn't have to be strictly an API. And I'll give you a few examples. So actually Gatsby is probably the easiest example. Is anybody familiar with Gatsby? Cool. All right, so Gatsby, as you know, uses GraphQL locally on your machine to create a cohesive query interface for all of your data so that you're not querying disparate APIs, you're actually just querying a local API in memory to do high performance static site generation. And that's really cool. And also Apollo. And a new bit of Apollo is that they have enabled local schemas in the browser for just like we implemented today, so that you can save data locally using the same interface that you would use to store data remotely. So you can have one cohesive interface, whether it's local state or server state. And so that's really cool. And also I have to plug my company, TakeShape, and we do a similar thing where we actually use GraphQL's portability as an advantage, where we actually load it into memory and are able to do really high performance static site generation without having to do the round trips to various APIs. So the third point and final point, and I was leading into it with that last slide, is that there's an amazing community around GraphQL and there's tons of tools. And so this is great for the JAMstack developer and the JAMstack developer who wants to get stuff done and not roll their own. And so I think more and more we'll see that GraphQL is going to become an indispensable tool in the JAMstack developer's tool belt. So questions, and then that's the GitHub. Sure.
We're not using that wireless mic with questions and use another mic for
Pretty often, our users want to upload CSVs or download big CSV files full of things and download stream PDFs. What's GraphQL support for things other than JSON?
Well, is this on? Hello? Okay. Well, GraphQL is great for coordinating those things. Actually, internally with TakeShape, we use GraphQL to coordinate uploads via S3. That's one thing. It's not an end-all be-all scenario for solution for everything. So if you're doing streaming video or something, or need to upload a gigabyte CSV file, it's not going to take it. You'd be better off with a streaming REST endpoint for that. It's not. But for content flexibility and for other tools in your app, it's a great solution. Sure. Anybody else?
So when you wired up the API, I assume for each movie it was being called individually.
Yep.
Does GraphQL have support for batching? Say if you're running into performance issues,
yes.
you're going to group those.
Yes. So there's a Facebook project called Dataloader, And so Dataloader basically captures, in Node.js, it captures every request that you make to the Dataloader in one tick and batches them all together and then sends them to the batch call of your API, and allows you to essentially, if you're dealing with a database or a backend that can handle a batch request, you can easily implement batch loading with something like Dataloader.
Cool. Yeah. Thanks.
Yep.
I want to ask about there is not rumors, but like GraphQL will and Redux, like GraphQL, we can use GraphQL for state management, like instead Redux, for example, and like I know that it's like there's in GraphQL subscriptions. Apollo provide like update properties to mutations and some like. And what is your company like TakeShape doing, like with also something with state management?
We use Redux. So we're the Apollo, the new state, that's hasn't even made it into Apollo core yet. So that's actually Apollo plugin currently. And so when we started working on TakeShape around 2 years ago, that wasn't a popular technique, and Redux was much more of a popular technique. So right now internally, if that's the answer you want, we use Redux. Whether I see that using GraphQL locally is a fit for some projects, certainly. If you have a project and you just need local storage for one aspect of your project, and otherwise you're satisfied by a remote schema, then I think it's like a great thing to not have to introduce a whole new technology in order to get just this one little bit of state. So that would be does that answer your question?
So in backend, how many languages does GraphQL support?
There's just like I was saying before, maybe it wasn't clear, but there are many implementations of GraphQL. So there's one for Ruby, there's one for Go, there's one for Elixir, and the resolution framework is the variable in there. So I showed you how resolvers worked in GraphQL JS, but dependent on your language, whatever's the better way of doing it, that would be, your language of choice probably has an implementation.
So is JavaScript the recommended language, or they are like equally recommended?
I would say go with what you're comfortable with, because while it is the reference implementation, it might not fit in with the rest of your app. There's no reason to use Node.js if you're not using it for the rest of your stack.
Got it. Thank you.
Yeah.
Any other questions? All right. Anything else, Andrew?
No. Sorry about the text size.